This is the Introduction to Digital Electronics 1, and in this class we are going to talk about the introduction and the course outline. And as an introduction, we define the purpose of the course as the aim of enabling the students to understand the number systems, the number codes, some basic Boolean algebra, logic gates, and their applications. That is the purpose of the course, and by the end of this lesson, the learner should be able to understand number systems and codes. Number two, appreciate arithmetic and logic operations that may be represented using different number systems. Number three, we should use the logic gates to design combinational and sequential circuits. Now looking at the course content, the first item that we will meet as we address the objective of this course is the number systems, and there are a number of them. We will meet with the decimal numbers, then we're going to meet other called binary numbers, and then we will talk about other number systems like hexadecimal numbers. I think they are not listed there. So we are going to see them in the next objective. So those are the two number systems that we are going to meet, and their conversion from one number system to the other. We are also going to talk about the signed binary numbers as well as floating numbers and how they may be represented using different number systems. Then the number codes may be classified or may be listed as below. We have the BCD numbers. We have hexadecimal numbers, or which are also called hexacodes. We have the gray code. We have another one called XS3, which we will not definitely look at, but the gray code is very significant in our work. Hexa is very significant, as well as the BCD. Alphanumeric is going to be shown as key, and how we may apply them in error handling and correction. We also use encode them for encoding, encode converters, that is ADC or analog to digital converter, and vice versa, that is digital to analog converter. And that is a part of what we are going to use code that we are going to meet in this course in their applications. So that is one of the applications of the number codes. The other objective that we should meet in this course is to look at the Boolean algebra, and that involves Boolean circuits, the truth tables, the circuits, the logic symbols, including their levels, and the Boolean expressions. We have some axioms that we are going to meet, as well as postulates of Boolean algebra, among others. We continue with the course objective, with the course content, and once we have been able to meet the introductory part, then we're going to talk about the minimization of Boolean expressions. And at this point, we're going to talk about some laws like De Morgan's theorem and additive laws, among others. We look at Venn diagrams, and to simplify further, we'll apply Kano maps, which may be in the form of sum of products or product of sums. And we also talk about universal gates, that is null and NAND, and how they may be used to implement any logic operation. After we have done that, we're going to talk about combinational logic circuits, in which case we're going to be able to build some devices such as comparators, encoders, decoders, multiplexers, and parity checkers. Then we will look at the sequential circuits. It's another long course which involves flip-flops, and once you're able to understand flip-flops, they come in various forms such as JK, SR flip-flop, D and T flip-flops, and these they enable us to create counters, and then we're going to look at different versions of counters such as Johnson and Ring, as well as the application in making of shift registers. That covers the course content of this course. And now we look at what we might need when we go to the lab. In the lab, we are going to do some experiments that are going to show you how you can verify which logic gates do what and how they function. Then you're going to employ those logic gates to come up with some combination of logic circuits such as adders and subtractors. And finally, we are going to do some conversion of different number systems such as decimal to BCD and BCD to decimal. Sometimes you might meet the technologies giving you different versions, but the objective of these lab exercises is to enable you appreciate what we have learned in class. So we now look at the mode of delivery, and I'm going to vary this slightly. The recommended mode of teaching is 2 hours of lecture and then 2 hours of tutorials per week. And then after we have done those arrangement every week, the program says that we should do at least 5 3-hour lab sessions which are done on rotational basis. Now here comes the modification. These 2 hours of lecture, I'm going to be employing what I've already introduced in a previous class, what is called blended instruction. And as I have already introduced, blended instruction involves me creating some video lessons which I share using our learning management system, and like I'm doing now with this video, and therefore my lectures are going to be handled as such. So they are not going to be necessarily 2 hours of lecture, they are going to culminate in me covering the entire syllabus. Then once we have done that, we are going to have some tutorials. Tutorials may be online or physical. This is may be online or physical. And that means that the tutorials are mostly here to help you solve problems that you may not have been able to do on your own. Therefore, this is out of class arrangements where I might be the one doing it, or I might ask a graduate assistant to assist me handle this work. But technically, the entirety of this course will be handled via the video recordings in the blended instruction model, but the tutorials are going to be done on the need by need basis, but the lab sessions are going to be handled by the respective technologist that has been scheduled to handle this course, and that you'll meet him or her in the lab. So beyond this, we see now that we need some materials, and of course, as we have mentioned, we're going to need the lab for you to carry out the experiments we have mentioned, and some equipment that you're going to need, as have been highlighted, is the whiteboard. This is more or less me needing this one, and of course mine is a digital whiteboard, so you don't need to get worried about that requirement. So we now talk about the course assessment, and the course assessment states that this course is evaluated as 10% of continuous assessment tests and assignments, in which case CATs take 10%, assignment take 5%, the labs will carry a higher weight of 15%, the final exam will take 70%, and that totals up to 100%. So at this point, I should mention that the CATs and assignments are going to be done online. So do not get worried, but trust me that the online assessment has been well prepared such that everyone will get their own version of the test by testing the same content. And for that reason, you will demonstrate on an individual level that you have been able to capture what is required. The labs you do together in groups. This one you can always organize yourself in the lab as guided by the technologist. This is where you meet, the rubber meets the road, in which case the final exam is a standard exam that has been done or agreed upon by the university, and as usual, this is a written hard copy exam. The total percent becomes 100%. We now talk about the core text, and the core text for this book is a book by Elijah Mwangi, a professor in the University of Nairobi, called Foundation of Digital Electronics, was last published or revised in 2009, a very well documented book, and it's available in your library. You can get it or you can buy for yourself in major. Another text that is of relevant you may refer to in this work is called Digital Design by Maurice Mano. I think I have not mentioned the year of publication, but this book is available even in the library. So that marks the end of this introduction. We meet in our first lecture soon.